Here's a right triangle whose legs measure A and B units and whose hypotenuse measures C units. Let's construct squares of sides A, B and C along each of these sides respectively. We'll call these square 1, square 2 and square 3. Now, we'll divide each of these squares into equal-sized squares. Let's count the number of squares along each side. You will observe that square 1 contains 9 squares, square 2 contains 16 squares, and square 3 contains 25 squares. We know that 9 plus 16 is equal to 25. In other words, area of square 1 plus area of square 2 is equal to area of square 3. As the area of a square is the square of its sides, we get a square plus b square is equal to c square. This is known as the Pythagoras Theorem. According to the Pythagoras Theorem, in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Consider a right triangle PQR that is right-angled at Q. We need to prove that PR square is equal to QR square plus PQ square. We first draw segment QX perpendicular to segment PR. In right triangles QXR and PQR, angle R is common to both triangles. Also, angle PQR is equal to angle RXQ as they are right angles. Therefore, by AA similarity criterion, triangle QXR is similar to triangle PQR. Since the corresponding sides of similar triangles are in the same ratio, the ratio of Rx to QR is the same as the ratio of QR to PR. This gives Rx into PR is equal to the square of QR. Similarly, we can prove that triangles PXQ and PQR are also similar by the AA similarity criterion. Therefore, the ratio of PX to PQ is equal to the ratio of PQ to PR. On cross-multiplying, we get PX into PR is equal to PQ square. Now let's add equations 1 and 2. Taking PR common from both the terms on the left side, we get the following. Now, Rx plus Px is equal to PR. Thus, PR square is equal to QR square plus PQ square. This proves the Pythagoras Theorem. Is the converse of the Pythagoras Theorem true? Let's find out. The converse of the Pythagoras Theorem states that given a triangle, if the square of its largest side is equal to the sum of the squares of its other two sides, the angle opposite the largest side is a right angle. Consider a triangle PQR, in which PR square is equal to PQ square plus QR square. We need to prove that angle Q is a right angle. To start with, construct a right-angled triangle XYZ, such that XY is equal to PQ and YZ is equal to QR, and angle Y is equal to 90 degrees. Since XYZ is a right triangle by Pythagoras Theorem, XZ square is equal to XY square plus YZ square. Since XY is equal to PQ and YZ is equal to QR, XZ square is equal to PQ square plus QR square. But it is given that PR square is equal to PQ square plus QR square. Therefore, XZ must be equal to PR. In triangles PQR and XYZ, PQ is equal to XY, QR is equal to YZ, and PR is equal to XZ. Therefore, by the SSS criterion for congruency, triangle PQR is congruent to triangle XYZ. Since corresponding parts of congruent triangles are equal, angle Q must be equal to angle Y, which is equal to 90 degrees. This proves the converse of the Pythagoras theorem.